Hi, this is Stu Schwartz from MasterMathMentor.com. This is Super Free Response Practice BC question number 4. Super free response questions are similar to the typical free response questions in past AP exams. But instead of having the usual 3 or 4 subparts, these will have a great many more. It allows us to use the problem setup as a source of many inquiries that can be taken and allows us to do an in-depth study of the situation. Because of that, many calculus concepts are tested and some reiterated. Doing these will take more than the usual 15 minutes, but by tackling all subparts, you will know what topics you need to emphasize as you prepare for the AP exam. It is recommended that you go to the MasterMathMentor website and download the PDF with the actual problem and subparts. If you don't have a printer available, use a piece of paper for parts A, B, C, etc. This video will just show you the solutions, although you can fast forward at times to bypass the solutions and just show the problems. BC04 is a problem dealing with power series and Taylor series and morphing into Taylor polynomial problems. There are generally 2 ways that these problems are presented. One way is to be given a function, and from that function, you change it into a power series. Based upon that series, we can find a Taylor polynomial of n terms. We can find the nth derivative of that expression at its center, and then determine the error in using the nth degree Taylor polynomial, either as an alternating series or a Lagrange series. And then finally find the derivative or definite integral of the Taylor polynomial. Or you could be given a series of n terms, and from there you need to find the general term of the series, and then find the radius of convergence, and from there determine the interval of convergence. Also, again, we can find the nth derivative of the series at its center. These are the basic types of situations that we will encounter. In this video, we will give both types of problems to make sure we cover everything. Problem Roman numeral 1 reads, let f of x equal sine of 3x over 2 minus x cosine of 2x. And the graph of the fourth derivative of x is shown to the right. A reads, write the first 3 non-zero terms and general term for the power series for sine of x about x is equal to 0. Little to do here, students should know this by heart. We assume that n will start at 0, so sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus dot dot dot. And the general term will be negative 1 raised to the n, x raised to the 2n plus 1 over 2n plus 1 factorial. 2 points for this problem. 1 point for the first 3 terms, and then 1 point for the general term. Part B reads, write the first 3 non-zero terms and general term for the power series for sine of 3x over 2, about x equals 0. We use our last solution, and wherever we see an x, we replace it with 3x over 2. So sine of 3x over 2 equals 3x over 2 minus 3x over 2 quantity cubed over 3 factorial plus 3x over 2 raised to the 5th over 5 factorial plus dot dot dot. This becomes 3x over 2 minus 3x quantity cubed over 48 plus 3x raised to the fifth over 3,840. We could expand the three x's, we choose not to. The general term will be negative 1 to the n times 3x to the 2n plus 1 times 2 to the 2n plus 1 times 2n plus 1 factorial. Points are the same as they were in Part A, 1 point for getting the first three terms and 1 point for the general term. Note that the graph of the fourth derivative of x hasn't come into play yet and may not for several subparts. Part C states to write the first three non-zero terms and general term for the power series for cosine of x about x is equal to 0. Again, this is a gimme. Students should know this right off the top of their head. Cosine of x equals 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus dot dot dot. And the general term is negative 1 raised to the n times x raised to the 2n over 2n quantity factorial. 2 points for this question, 1 point for the first three terms, and then 1 point for the general term. Part D asks to write the first three non-zero terms and general term for the power series of cosine of 2x about x is equal to 0. We use our answer in Part C and replace x with 2x. So we get cosine of 2x is equal to 1 minus quantity 2x, quantity squared over 2 factorial, plus quantity 2x to the fourth power over 4 factorial, plus dot dot dot, and the general term is negative 1 to the n times 2x quantity to the 2n power over 2n quantity factorial. Same point structure as in C, 1 point for the first three terms and then 1 point for the general term. E reads, write the first three non-zero terms of the power series for f about x is equal to 0. As a reminder, we put the definition of f, which is sine of 3x over 2 minus x cosine of 2x, below. This problem uses b and d. We know that sine of 3x over 2 is 3x over 2 minus quantity 3x to the third power over 2 to the third times 3 factorial plus quantity 3x to the fifth power over 2 to the fifth times 5 factorial. We then subtract x cosine of 2x, which is x times 1 minus 2x quantity squared over 2 factorial plus 2x quantity to the fourth over 4 factorial plus dot dot dot. So therefore, when we subtract sine of 3x over 2 minus x cosine of 2x, we get 3x over 2 minus 9x to the third over 16 plus 81x to the fifth over 1,280 plus dot 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 minus x plus 2x to the third minus 2/3 x to the fifth plus dot dot dot. So the fifth degree power series, or if you want the fifth degree Taylor polynomial, is x over 2 plus 23x to the third over 16 minus 2,317 x to the fifth over 3,840. 3 points for this problem, 1 point for each term. F reads, find the value of summation n equals 1 to 5 of the nth derivative of f at 0 and place it in either fraction or decimal form. Recall from Part E that f of x can be approximated by the fifth degree polynomial x over 2 plus 23x to the third over 16 minus 2,317 x to the fifth over 3,840. Summation n equals 1 to 5 of the nth derivative at 0 is simply the first derivative of f at 0 plus the second derivative of f at 0 plus the third derivative of f at 0 plus the fourth derivative of f at 0 plus the fifth derivative of f at 0. Recall that the nth derivative of f at 0 over n factorial represents the coefficient of x to the n in the Taylor series for f about x is equal to 0. So the nth derivative of f at 0 is simply n factorial times the coefficient of x to the n. So f prime of 0 is 1 times 1/2. F double prime of 0 is the same as the fourth derivative of f at 0, which is 0. The third derivative of f at 0 is 3 factorial times 23 over 16. And the fifth derivative of f at 0 is 5 factorial times negative 2,317 over 3,840. So, summation n equals 1 to 5 of the nth derivative of f at 0 is 1/2 plus 69 over 8 minus 2,317 over 32. And that gives negative 2,025 over 32, or negative 63.281. 3 points for this problem, 1 point for f prime of 0, 1 point for f triple prime of 0, and 1 point for the fifth derivative of f at 0, and the final answer. Part G reads, let P3 of x be the third degree Taylor polynomial for f about x is equal to 0. Explain the meaning of the absolute value of P of 3/4 minus f of 3/4, and given the nature of the series, classify it with a name. The expression looks scary, but it is quite simple. The absolute value of P3 of 3/4 minus f of 3/4 is the absolute value of the difference between the actual value of f of 3/4 and the third degree Taylor polynomial approximation for f of 3/4. We saw previously that f of x can be written by the fifth degree Taylor polynomial, x over 2 plus 23x to the third over 16 minus 2,317x to the fifth over 3,840. This series is clearly not an alternating series, so the error that we are showing represents the Lagrange error. 2 points for this problem. 1 point for recognizing that this absolute value represents an error bound, and then 1 point for the classification, calling it the Lagrange error. In H, you are asked to use information from the graph of y is equal to the fourth derivative of f of x shown to prove that the absolute value of P3 of 3/4 minus f of 3/4 is less than 1/2. As stated, this expression is the Lagrange error. The Lagrange error for the nth degree Taylor polynomial approximation for f of k is given by the maximum value where x runs from 0 to k of the nth plus first derivative of x all over n plus 1 factorial times k raised to the n plus 1. Since we are working with the third degree Taylor polynomial, we are interested in the fourth derivative of x, and we have a picture of that. This graph indicates that the maximum value where x runs from 0 to 3/4 of the fourth derivative of x, whose absolute value we're taking, has to be less than 30. We see that because at 0.75, the fourth derivative is somewhere between negative 25 and negative 30. So the absolute value of that will be between 25 and 30. We don't know where it is, and 30 is a convenient number to use. So the absolute value of P3 of 3/4 minus F of 3/4 has to be less than the maximum value, where x runs from 0 to 3/4 of the fourth derivative of x, absolute value of that, over 4 factorial times 3/4 to the fourth, has to be less than or equal to 30 over 24 times 81 over 256. Do the math and you get 405 over 1024, and that is less than 1/2. In the Lagrange error, there are two parts. First, we use the maximum value of the fourth derivative of x being 30, and we get a point for that. 1 point for the other parts of the Lagrange error, the 4 factorial and 3/4 to the fourth. And then 1 point for the analysis showing that the Lagrange error is less than 1/2. I reads, let g of x equal sine of 3x over 2 plus x cosine of 2x. It can be shown that this series is alternating. Let q3 of x be the third degree Taylor polynomial for g about x is equal to 0. Determine if the error using q3 of x to approximate g of 1/2 is less than 1/10. We first find the expression representing sine of 3x over 2 plus x cosine of 2x. Using the previous analysis, we have 3x over 2 minus 9x to the third over 16 plus 81x to the fifth over 1280 plus plus x minus 2x to the third plus 2/3 x to the fifth. And that is 5x over 2 minus 41x to the third over 16 plus 2803 x to the fifth over 3840 minus . We are interested in the third degree Taylor polynomial, so q3 of x equals 5x over 2 minus 41x to the third over 16. And since this has been defined as an alternating series, the error is simply the next term in the series, which is 2803 over 3840 times 1/2 to the fifth power. Doing the arithmetic, this is 0.023, and that is less than 1/10. 2 points for this problem, 1 point for generating Q3, and then 1 point for the alternating error. J reads, determine the largest possible value of C, where C is greater than 0, such that the error in using Q3 of x in part I to approximate G of C is less than 1/10. The alternating error we showed was 2803 over 3840 C to the fifth, and that value has to be less than 1/10. So that gives us C to the fifth has to be less than 3840 over 28,030. Doing the arithmetic, C to the fifth is less than 0.137, and therefore, if we raise both sides to the 1/5 power, we get that C is less than 1.137 to the 1/5 power, which is 0.672. 2 points for this problem, 1 point for the equation, and then 1 point for the value of C. The last question for part 1 is K. Let h be the function defined by h of x equals the integral from 0 to x of g of t dt. Use the Taylor polynomial found in part I to approximate the average value of h on the closed interval 0 to 1/2. The average value of h is the integral from 0 to 1/2 of 5x over 2 minus 41x to the third over 16 dx, all divided by 1/2 minus 0. This is 5x squared over 4 minus 41x to the fourth over 64, evaluated from 0 to 1/2, all over 1/2. This is 5/16 minus 41 over 1024, all divided by 1/2, And doing the arithmetic, we get 279 over 512, and our average value is 0.545. 3 points for this problem, 1 point for doing the integration, 1 point for the division, and then 1 point for the final answer. 2 reads, the Taylor series for a function f centered at x is equal to 1 is given by 1 minus 2/5 quantity x minus 1 plus 3/25 quantity x minus 1 squared minus 4 over 125 quantity x minus 1 cubed plus dot dot dot. The first thing you're asked to do is in L to express f using sigma notation. There is no one correct way to address this problem. You have to look for patterns. If we're using sigma notation, our first decision is whether to use n going from 0 to infinity or n going from 1 to infinity. It makes no difference, but we have to choose one. Realize that this is an alternating series with the terms going from positive to negative to positive to negative, etc. So if we use n equals 0 to infinity, then we need a negative 1 to the n power. If we have n running from 1 to infinity, then we have negative 1 raised to either the n minus 1 power or the n plus 1 power. Makes no difference. We have to then take care of the coefficient. We go from 1 to 2/5 to 3/25, etc. If n runs from 0 to infinity, our numerator is simply n plus 1, and our denominator is a power of n, 5 to the n. If n runs from 1 to infinity, then again we have our numerator starting at 1 and going up, and our denominator now is 5 raised to the n minus 1 power. Finally, we have our x expression. It is always an x minus 1, and it will either be an x minus 1 to the n, if we are using n running from 0 to infinity, or x minus 1 to the n minus 1, if n is running from 1 to infinity. So there are several answers that we can give. Summation n equals 0 to infinity of negative 1 to the n plus 1 over 5 to the n times x minus 1 to the n power. And we can combine the negative 1 to the n on top and the 5 to the n on the bottom and write this as summation n equals 0 to infinity of negative 1/5 to the n power times n plus 1 times x minus 1 to the n. Or summation n equals 1 to infinity of negative 1 to the n minus 1 times n over 5 to the n minus 1 times x minus 1 to the n minus 1. And again, we can utilize the fact that both the negative 1 and the 5 have an n minus 1 power. We can write this as summation n equals 1 to infinity of negative 1/5 raised to the n minus 1 times n times x minus 1 to the n minus 1. 3 points for this problem, 1 point for addressing the alternating series aspect of it, 1 point for the n term, and 1 point for the x term. Question M reads, suppose the series converges to f of x for the absolute value of x less than r, where r is the radius of convergence of the series. Use an appropriate test to find r. We will solve this using one of the forms of the series we just created. I will use summation n equals 0 to infinity of negative 1/5 raised to the n times the quantity n plus 1 times the quantity x minus 1 raised to the n. We will use the ratio test, looking at a sub n plus 1 over a sub n, where a represents a term. So the n plus first term is negative 1 to the fifth raised to the n plus 1 times quantity n plus 2 times quantity x minus 1 raised to the n plus 1. And we will put that all over the nth term, negative 1/5 raised to the n times quantity n plus 1 times quantity x minus 1 raised to the n. And as we look at the limit as n approaches infinity of that expression, we get the limit as n approaches infinity of the absolute value of negative 1/5 times x minus 1. And that expression has to be less than 1. So from that, we can say that the absolute value of x minus 1 has to be less than 5, meaning that the radius of convergence, r, has to be equal to 5. 3 points for this problem. 1 point for using the ratio test, 1 point for computing the limit of the ratio, and then 1 point for the radius of convergence, r. Question n reads, find the interval of convergence of f. Show the steps that lead to your answer. We start with the answer that we just got. The absolute value of x minus 1 is less than 5, meaning that x minus 1 is less than 5 and x is less than 6, or negative x plus 1 is less than 5 and x is greater than negative 4. So when we write our series out, f of x equals 1 minus 2/5 quantity x minus 1 plus 3/25 x minus 1 quantity squared minus 4 over 125 times the quantity x minus 1 raised to the third plus dot dot dot. When x is equal to 6, our series becomes 1 minus 2 plus 3 minus 4, and this is divergent by the nth term test. We also look at f of negative 4, and that becomes 1 plus 2 plus 3 plus 4, and that is also divergent by the nth term test. So the interval of convergence is the open interval 4 to 6. 3 points for this problem, 1 point for the correct endpoints 4 and 6, 1 point for showing divergence at 6, 1 point for showing divergence at negative 4. Question O is slightly different. Explain why f of 0 is or is not a geometric series, and then use the result to either find the value of f of 0 or find a lower bound for f of 0. First, let's find f of 0. Plugging in 0 for x, we get f of 0 is 1 plus 2/5 plus 3 over 25 plus 4 over 125 plus dot dot dot. At first glance, this looks geometric, but it is not, as the geometric series with r equals 1/5 is 1 plus 1/5 plus 1/25 plus 1 over 125 plus dot dot dot. We know the sum of this geometric series is 1 over 1 minus r, which is 1 over 1 minus 1/5, and that is 5/4. Looking at f of 0, we know that f of 0 is greater than 1 plus 1/5 plus 1/25 plus 1 over 125 plus dot dot dot. So therefore f of 0 has to be greater than 5/4. 3 points for this problem, 1 point for the not geometric reasoning, 1 point for finding the sum of the geometric series, and then 1 point for explaining the lower bound. Question P asks us to find the 20th derivative of f at 1. We write our f of x as 1 minus 2/5 quantity x minus 1 plus 3 over 25 quantity x minus 1 squared minus 4 over 125 quantity x minus 1 to the third plus dot 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 plus. And now this is where you have to do a little bit of thinking. The x minus 1 to the 20th term will have a coefficient of 21. And also the denominator will be 5 to the 20th power. And it will be positive because the odd terms are positive, and the odd terms have even powers of x minus 1. Realize that the nth derivative at 1 over n factorial is the coefficient of x minus 1 to the n in the Taylor series for f about x is equal to 1. So f nth derivative of 1 is equal to n factorial times the coefficient of x minus 1 to the n. So therefore, the 20th derivative at 1 will be 20 factorial times 21 over 5 to the 20th power. And 20 factorial times 21 is simply 21 factorial. And our answer is 21 factorial over 5 to the 20th. 3 points for this problem, 1 point for the sign, 1 point for the numerator, 21 factorial, and 1 point for the denominator, 5 to the 20th power. Q reads, write the first 3 non-zero terms of the Maclaurin series for e to the x minus 1 power. This is a gimme problem. Students should know that e to the x is 1 plus x squared over 2 factorial plus dot dot dot. So e to the x minus 1 is 1 plus x minus 1 plus x minus 1 quantity squared over 2 factorial plus dot dot dot. 2 points for this problem, 1 point for e to the x, 1 point for e to the x minus 1. Finally, question R reads, use the result in Q to write the second degree Taylor polynomial for g of x equals e to the x minus 1 times f of x about x equals 1. E to the x minus 1 times f of x is the quantity 1 plus x minus 1 plus x minus 1 quantity squared over 2 plus dot 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 times the quantity 1 minus 2/5 x minus 1 plus 3/25 x minus 1 quantity squared plus dot dot dot. We are interested in the highest power term being a second degree. So if we multiply the 1 in the first expression by all the terms in the second expression, we get 1 minus 2/5 x minus 1 plus 3/25 times x minus 1 quantity squared. Any other terms will have a higher power of x. We then multiply the x minus 1 times the first two terms of the second expression, and we get x minus 1 minus 2/5 x minus 1 quantity squared. And finally, we multiply in the first expression x minus 1 quantity squared over 2 times 1, getting x minus 1 quantity squared over 2. Those are the only terms that will have powers less than or equal to 2. Putting it all together, we get 1 plus 3/5 quantity x minus 1 plus 11/50 x minus 1 quantity squared. 3 points for this problem, 1 point for the constant, 1 point for the x minus 1 term, 1 point for the x minus 1 quantity squared term. There is a total of 45 points available for this problem. There is no exact formula for what number of points will constitute a 5, 4, 3, 2, or 1 on the AP exam. However, these percentages are what have been used in the past based upon exams released by the College Board. While you can extrapolate for just this question, realize that this question only tests a limited number of AP topics. So it is recommended that you do a number of the super free response questions in this series. Then combine your results, total your points, and then use these percentages to get a feel for how you will do in the AP exam. And more importantly, what concepts you need to strengthen in order to improve your score.